Hi. Whoa, this is an almost full room. Awesome. So when I prepared this talk, I realized that this is going to be a much more personal presentation for me than I expected, because almost everything in my life can be traced back to this machine in one way or another. So this presentation starts in 1982. In April in 1982, the ZX Spectrum was released in Europe. It was the best-selling British home computer. It sold around 5 million devices. How many of you had one? Fewer than I thought. How many have had Commodore 64? Oh, okay. So in August of the same year, the Commodore 64 came out. The Commodore 64 sold around 13 to 17 million, so a lot more than the ZX Spectrum. The C64 was the second most popular computer in the UK after the ZX Spectrum. Now, the cool thing with the ZX Spectrum, or the Spectrum in general, was that there were a lot of clones all around the world. 5 official versions and over 70 unofficial versions, according to Wikipedia, if that's a source, I don't know. So clones plus official ones is estimated to have sold 13 million devices. So that's quite a lot. The second most important thing that happened in 1985 was that I saw Empire Strikes Back for the first time. Now, the really annoying thing was that I already seen Return of the Jedi. So I'm introducing the new way of seeing Star Wars, the Jimmy way, 465. Not recommending it. That was also the year that my parents got me, you probably already guessed it, my first computer, my ZX Spectrum. I remember I sat down, I connected everything, and I sat down, and 10, print Jimmy, 20, go to 10. And that was my code. I made the computer do things. And I remember that this was a very defining moment for me, because this was the moment that I decided that I wanted to become a developer. Now, back then, we didn't bring out the camera for everything. We didn't take an image of what we were eating and stuff like that, like we do today. So this is the only image that I've found that is with me. That's me. And somewhere here is the ZX Spectrum, and that's my sister. The Spectrum, that was really cool with the Spectrum, was that it had 15 colors. Now, you might not see that, but that's a black and white TV. 15 shades of gray, yay. But here's where I come into the story. My name is Jimmy. I'm a Microsoft MVP, and I love ZX Spectrum, and I love Blazor. So that's where this talk comes together. Now, back then, we didn't have any internet. We had books. How many had books like these? Yeah. This even comes in different languages. This is I think this is a Swedish one, yeah. And I know there's a German one, there's an English one, and stuff like that. And we also had magazines with code. So you had to type all this code to make the application run. Now this one is pretty understandable. Now this one is a little bit more tricky. I mean, back then, we didn't have GitHub. So this was GitHub, basically. This is how we shared code between developers. My brother, which is the one on your left, standing up, he wrote reviews and even code for Expressen in Sweden, which was kind of cool because they actually had code inside of the daily newspaper. There were even community radio broadcasts that was broadcasting Spectrum games kind of like Pirate Bay, I guess, of the time. So this proves how mainstream the ZX Spectrum was in the 80s, which I think is mind-blowing. Now, the year passed. I got a ZX Spectrum 128, I got an Amiga, I got a Commodore 64, followed by PC. I was very interested in emulation back then, and my first web page was about emulation. And I can't believe I'm actually going to show you this. It's recorded, isn't it? Oh, God. So this is my first web page. So back then, I thought that Microsoft front page, this is something I should put on my page. I should have this as an animated GIF, because this is awesome. So despite this, in 1999, I got a job as a web developer. I don't think I showed them this page. I hope I didn't. But back then, I was working with ASP. Now, I was interested in emulation, as I mentioned, and in 2002, the Xbox came out. So this is where the idea of emulation came back to me. Now, I knew I wanted to do an emulator. I'm going to create an emulator for the Xbox. But I didn't know enough C++ to actually make that happen. I knew a little bit of C++ and C, but not even close to as much as I should. So there was a Swedish guy that took Fuse, which is one of the best emulators for the ZX Spectrum, and he ported it to a Pocket PC. Pocket Clive was the application's name. And I talked to him, and he showed me what I needed to know, and more importantly, what I didn't need to know, so what I didn't have to implement. So I actually got it working. Now, I didn't have any screenshots more than this one, which is a work in progress. But the problem with the Xbox was that the XDK was not open. You had to hack your Xbox. So releasing this kind of died off. But you will see the name ZXbox later in the presentation, so that's where the name comes from. In 2002, .NET came out. And I dove being an ASP developer, I dove right into VB.NET because this is going to be the future. And my colleagues said, no, we're not going to do that. We're going to go with C#. And I'm like, why? We know VB. We know VB. This is VB.NET. We're going to go with that one. And he said, no, because we're going to bring over all our bad habits to VB.NET. So don't do that. Go with C# instead. I have not regretted that decision, to be honest. So around 2006, XNA came out. And there was possible to write games for the Xbox 360. And I'm like, whoa, now it's time. It's time to create the emulator, but in C# instead. So I bought a book. This book from eBay. And I opened it, and I started implementing it. One instructions after another. But before we go into exactly that, let's talk about the CPU. So the CPU can do things, right? And what it does is there is an opcode, an operation code, that does something. And it has a limited amount of things it can do. It's all about assembly instructions. It takes something from a part of the memory, push it into another part of the memory, or a register, or whatever it may be. Now, the problem here is that ROMs generally is not allowed to distribute them. You're not allowed to distribute them. But the nice thing is that in 1986, Amstrad bought Sinclair. And they say, you know what? You can distribute this as much as you like. You need to say it's Amstrad or Sinclair, and you're not allowed to change it in any way. So this means that the ZX Spectrum is one of the few emulators that is actually legal to distribute, which was a win for me. So the ZX Spectrum has a bunch of different registers. So you can think about them as bytes. It's 8-bit registers. And you can combine these, so you get a 16-bit register, which is going to be important in a little while. So what I did was that I just created an array with registers and prime registers. Now you might think, why do you have an int and not a byte? And I cannot answer that question. At some point during the development, I thought this was a good idea. I think I need to refactor this at some point. But this is what it looks like right now. I also have some nice properties. So I can access the A register and so on. And some nice properties that can get the combined value as well. Now, I'm a self-taught C# developer. I've never done any courses and stuff like that. And when you're looking at these kinds of bit shifts and AND operators, that is not something that you work with in a daily basis, or at least I don't. So this has been a really challenging to find out find those other things that I don't normally do. So let's take a look at what's happening here when we're talking about running things. So this is the memory, or a representation of the memory. And we do have a program counter, a position in the memory. So when we have executed that, it's going to move +1. Not always, but that's generally what's happening. So now we're pointing at 78, hex 78, which looks like that. Now the binary representation looks something like that. And what that instruction does is it loads the A register with a value from the B register. So now, my trusty book, again, let's take a look what is happening. So this is what the book said. So 01 followed by the source register followed by the destination register. So the opcode has everything I need to know for what I'm supposed to do with this instruction. Now I had an implementation of this, and while I was writing this presentation, I didn't realize that it was the code actually looked like that until now, just recently. So I had an opportunity. I can refactor this. I can make this work even better, but we're going to come back to that in a second. So here we also says that it takes 4 t-states. Now a t-state is some kind of timing, and it's 69,888 t-states per frame update. So that's how much the CPU can do before it has to show an image. And down here we'll also have some kind of nice matrix that we can see that we're going to load the A register from the B register. And also, we're not going to talk a lot about flags, but we can see here that the flags are not changed in any way. Okay, so with this piece of code, I can get the register that I'm supposed to work with from the operation, from the opcode. So in this case, it takes the opcode, it moves it, it bit shifts it, might bit shift it, I should say, and then bit masks it with a 7. So this is what that looks like. So we have 78, the bit mask of 7, which gives us 0. Actually, we moved it by 0, sorry. We're moving it 3 bits, and then we are adding we are bit shifting it, no, bit masking it with 7, and we get 0 back. So looking at the book again, we see that 0 is the B register. So that seems like it is as it should. So now we're running the code. The execution could look like that. So we have 78, put the value of B into the register A. And then it took four T states, so we're going to subtract that. Awesome. But we had a bunch more, right? We had the A register, F register, B, C, and all of those. So I would have to write this code 7 multiplied by 7 times, so 49 times, if my math is not totally wrong, I don't know. So so what I could do is that I could read out the register from the opcode, so I can get it a little bit. Now I only have I have way fewer, but I still have the A there. So this is what I noticed. Okay, I could get the destination register as well. So now the code would look something like that. No, this is the, sorry. So let's go back. So the case statement looked like that. But with C#9, I noticed that I can change it to this instead, which is a little bit smaller. But I still have the A register in there. So again, doing some clever refactoring, I could change it to this instead. So this is all those 49 times whatever. I think it was around 80 lines of code. Is now only this. Only this. Which brings us to the memory. So when we're talking about emulation, it's only we're really talking about manipulating memory in some way. It could be a register, it could be a piece of memory, and we're just moving data around. So the memory had a little bit of ROM, a screen, it has screen attributes, printer buffer, and a little bit of stuff, and then we have the big chunk of memory. Now the cool thing here is that all of this is addressable by a 16-bit variable. That's why it's so important that we can combine the two 8-bit registers. The 128K version of the Spectrum has banks. So it still has 16-bit of addressable memory, but we can switch out parts of the memory if we'd like. All right, the screen, 256 times 192 pixels. It has a little bit of border, which we'll come back to. My emulator has a setting, so we can say how much of border we want. Now, I couldn't wrap my head around this because it's stored in a very odd way. So I had a colleague that helped me implement that, but I've later implemented it myself. But for the first version, he helped me. So if we fill the screen memory from top to bottom, this is what's going to happen. It's going to fill 1, 9, 2, 10, 3, 11 in 3 segments, top, middle, and bottom, which is super weird. So I hope you understand why I didn't get my head around that. Now, the real cool thing is that it doesn't have a pixel, so it should be pixel here. It's actually whether or not it should be paper or ink. And the paper or ink is settable by attributes, which we will come back in just a second. So I mentioned 15 colors, but it also has a bright version of every color. So I have 15 colors, I have 8 colors and a bright version of that. But the black is always black, so that leaves us 15. Or how I saw it. So after the memory, I mentioned the attributes. So after the screen memory, we have the attributes. So that's 8 by 8 pixels telling us what color is the ink, what color is the paper. Should it use the bright colors, and should it flash or not? So if we're loading my favorite game, Jetpack, oh, the sound, awesome. So we're loading, you see the 1, 9, 2, 10 and all of that. And then at the end, we are filling the attributes. That's why it looked like that. You also see all of these borders. So that's all about how it's written, the point that it's written to the out port. That's how that the border works. I'm not going to make you listen to that, the whole talk. But I thought, for me, that was so fascinating, because when I had a Spectrum, I didn't know all of these things. This is something I learned now, basically. So I mentioned the border, timing. It's all about timing. So it's writing to the out port, changing the color, changing the color, changing the color, changing the color, while it's updating 50 frames per second. That's how you got those lines. So let's talk about in and out ports. So the Spectrum has an in port and an out port. An in port could be the keyboard, which has all the commands inside of the basic commands is in the button. So if I would press load, for example, I would just press J and it would show me load. I could not write LOAD. That wouldn't work. This is actually a slide that I found. So someone has done this completely in PowerPoint, which is kind of cool. The sound is a 1-bit sound. So it's all about switching up or down in a frequency which makes the sound. So it's not like 1 means that it's making a sound. It's actually the switching up and down that makes the frequency and builds up the sound. So what are the challenges of building an emulator? Well, first of all, when you're reading up on this, you're going to read about the hardware. So what the heck does it mean that the mic and the ear port has a resistor between them? I have nothing. So you have to kind of convert the hardware to something that you can write in code. Now this has really kept me on my toes, because you can, since this is, the ZX Spectrum is running 50 frames per second, which means that there's no time for garbage collection. So you need to basically have all the variables as temp variables as fields, no unnecessary allocations, and of course bit shift and all of those things. You had to learn all of that stuff. So around 2006, 2007, I got my first version of, this should play, shouldn't it? There we go. I got my first version running on the Xbox 360. Now this is a very old video, as you can see, but this was the only one. I didn't bring out my 360 for recording a better one, to be honest. It had keyboard support, but no sound at this point. Now, someone beat me to it. Someone released an Xbox 360 ZX Spectrum emulator for the 360. And I'm like, kind of lost interest. So a couple of years later, I had a really bad day at work. We've been working, switching back office systems, and I believe I came home around 1 a.m. or something like that. But that day, a new version of XNA had dropped, which I could run on my Zune. Did anyone have a Zune? One? Thank you. I'm not alone. So I sat down, I came home, I sat down, and I started coding. And my wife, Jessica, comes in and says, "What are you doing? Are you still working?" I'm not, "No, yeah, maybe." "What are you doing?" Okay, so a new version of XNA came out, and I had just had to try it. And I got it working in like, I think it took like an hour or something like that, porting everything over and get it to run. Now, this was one of the things that Jessica used and sent into Microsoft Tech Days. So in 2011, this was actually my first time meeting Magnus Mortensen, if you know him. I was on my first conference, Tech Days, in Øredev. And I received my award as Geek of the Year. I'm pretty proud of that. But that opened a lot of doors for me because suddenly Microsoft Sweden knew who I was. So later that year, I was standing on stage at Microsoft and I was showing off a Windows Phone app that I built, Stockholm Travel. And one of my friends, Johan, who is also speaking here tomorrow, he said, "Jimmy, couldn't you just show the emulator? You got to show it." So I showed the emulator, and I got the first and only spontaneous applause that day. And that made me think that, hey, you know what? Maybe public speaking is something that I should do. That sounds, this felt really good. And there was new toys. I got the Gadgeteer, got it running there. When Windows Phone, I think it was Mango update came out, I made a 3D model for augmented reality. So the 3D model you saw in the beginning, that's I did that in SketchUp. First and only 3D model. So I tested out the 3D model, and I thought, this is kind of cool. But it would be cooler if I could run the emulator as well. So that's absolutely what I did. If I can get the video to play, there we go. So this is an augmented reality version of the ZX Spectrum emulator. I think I'm going to press the screen. There we go. And it's running there. It even has sound, but I muted that one. So a couple of years later, I was contacted by a company called Elite. And they own the rights to hundreds of ZX Spectrum games. And they said, you know what, we would love if you could do a Windows Phone version. How many have Windows Phone? Oh, happy to see that. But the sound was still a little bit off. I wasn't happy with the sound. So I actually exported the sound to Excel, looking at the ones and zeros, trying to figure out what was wrong, and I managed to figure it out eventually. So in 2012, the first Windows Phone version of Manic Miner came out. I have still not beaten the first level. It's insane. So Elite said, you know what, we want to create Windows 8 application as well. Could you please help us with that? And I'm like, yeah, sure, why not? So I started porting. They wanted a Windows RT version, so I ported the emulator all to C++ because C# was just not fast enough for Windows RT. So I ported everything to C++, still used XNA and C#, so I just made calls for the actual emulation in C++. So I think I made 108 different games for Windows 8 for Elite. Later that year, Xbox opened their indie program. So this is the Xbox 360 version of Manic Miner. And this was a very interesting experience because the indie program was tested by other developers. So other developers came with the feedback. And working with, I mean, these persons really try to mess things up. They're like, I got some feedback. Yeah, so if we press load the game and we jank out the cord for the controller, it freezes. Who does this thing like that? But after a couple of tries, we got it into the store. I believe we got Chucky Egg as well in the store. It was a really fun experience. Now, I travel around the world. I meet a lot of awesome speakers and attendees. So we started a podcast called Coding After Work. We also have a Twitch channel and a YouTube channel and all of that. We do a lot of Blazor stuff and stuff like that. So the first thing you do is not record something. You need a theme. You need something that to start a podcast. So I asked my friend, you know what? I know you do amazing 80s music. Could you do a podcast theme for us? And he said, yeah, sure. So what do you want? And I'm like, vocoders? Is that an option? Okay, I get it. I know you. I know what. Let me do something here. So he knew that I love vocoders. Vocoders make everything better. He knew that I loved Kraftwerk. He knew that I loved Depeche Mode, the Speak and Spell era. But he also hid one little Easter egg, because he also knew that I loved the ZX Spectrum. And I had a Cura microspeech. Did anyone have one of those? No? So that's kind of a vocoder, or speech synthesis, for the ZX Spectrum. So if you would press the J button, it would say load. And then J-I-M-M-Y. This is what I spent hours with this. So he added just a little bit of ZX Spectrum into the song. Okay, I'll stop. That's what I'm talking about. A lot of things in my life has some kind of connection to the ZX Spectrum. Then Hololens came out, and that was so cool. And what do you need to do with the new technology? Yes, you guessed it. We need to have the emulator running there. So this is the emulator running inside of Hololens. This is, by the way, my favorite game, by far. Okay, so this brings us into Blazor. So in 2018, the first version of Blazor came out, and I showed my colleague. We just finished a delivery, and I showed my colleague, I just want to show you this is kind of cool. So I showed him just a simple demo with a select box. And he was like, we're doing this. This is what we're going to push this into production. I don't care. This is so awesome. So 7 days later, we were running in production. Just a little part of the website, but still running. And being a fan of Blazor, I wrote a book about Blazor. And this is the only Blazor book. Actually, it's not true. This is the second Blazor book with a raccoon on the cover, because I'm working on the second edition. So the first edition has 2 raccoons, and the first edition has 2 raccoons. The second edition has 1 raccoon. I guess it should be the other way around, but I didn't have much saying in. Well, I did have a lot of saying because I really fought for the raccoons. So when we're starting to emulate things and porting it to a new platform, you need to think about what kind of things that what kind of things are platform specific. Now, sound is one of them. So the fun thing is that it touches a lot of tech. It's touching drawing, it's touching sound, it's touching devices. I'm going to come back to that in the next slide. But what we're doing is that we are pre-rendering 20 milliseconds of sound, pushing that to JavaScript, and the JavaScript and queuing it in JavaScript and playing the sound. So every 20 milliseconds of sound is queued up. Now, gaming is, of course, known for game paths and stuff like that. And there's a guy, Mr. Sakamoto, which is a fellow MVP, that has done a controller library. So we can connect, in this case, an Xbox controller or whatever controller we have, and connect that to Blazor. The keyboard is the same thing, that I need to write something specific. So this is capturing in JavaScript, capturing all the keystrokes, saving them away so that the emulator can check with the JavaScript and get the current keys pressed. The canvas has a lot of bytes. It has 206 kilobytes of data. So that's all the pixels from the screen in RGB. So what I'm doing here is that I am allocating a little piece of memory. And this is something that I think is really, really cool with Blazor, because I can allocate a little bit of memory, get that address, push that over to the paint canvas method, and free up the memory. And then on the JavaScript side of things, I can get that pointer to the memory and read that directly. So I don't have to send that over into an interop into JavaScript, but I can use the same memory, which I think is really, really cool. Blazor came with AOT, ahead of time compile. So by default, it's around 10,000 assembler instructions running per frame, 50 frames per second. So I have to run 10,000 assembler instructions. I have to generate 20 milliseconds of sound. I need to paint more than 200 kilobytes of pixels, and I need to do that in less than 20 milliseconds, which is quite fast. Which is insane when you think about it from a computer from the 80s. But ahead of time compile actually made it possible, because that makes Blazor super, super fast. So let's take a look at the emulator. Make it run. So I have the 48K version and the 128 version. So I can start it. Can load Manic Miner. There we go. I can even play it, I think, at least. There we go. And it's bugging. This is a super bad demo. Don't look. Look away! Let's try that again. What's up? There we go. So as I mentioned, I never finished this level, so I'm not going to do that this time either, I believe. So this is the emulator in action. So we're kind of running out of time, so let's kill this one first. There we go. So what does the future hold? Well, I would love to do the current micro-speech, because that would be so cool. Did anyone have a printer for the ZX Spectrum? Yeah? Do you remember the smell? The smell of burnt aluminum? It should be kind of easy to emulate, not the smell, but I would love to do that as well. But that is some of the things that I would love to do in the future. So the Spectrum is the reason that I decided that I wanted to become a developer. It's the reason I became a developer. It's the reason I met my wife. It's the reason I became a public speaker, the reason I became an MVP, the reason that I can travel the world and meet all of you amazing people here in Malmö. So thank you so much for being part of my journey, and please reach out.